or is that not an option?
I'm not very sure about how this thing works.
Okay.
So this is all the Rishwin and others have set it up in some specific ways that I follow blindly instructions that have been given to me.
We are live.
Okay. Well, welcome everyone. Well, thank you for joining this session on data governance and semantics. My name is Amit Kapoor, and I'm probably going to just take about 5 minutes to set the context of why we are here and what we're planning to do with this set of series of talks that we are doing. Right? So, data governance, is a really important topic, especially now, and it kind of cuts across the business, the product, and engineering. And more people are realizing both kind of the benefit of doing data governance as well as kind of the risks of not doing it really well, right? And most of the current dynamics around privacy and operational risk, as well as kind of benefiting from the data, requires us to rethink how we are doing data governance, whether you are in a startup mode, whether you're in a larger organization, or for India, are in a governmental position. And what I really like about Hasgeek is they've been talking about this, and we're doing this talk under this banner of privacy mode, and Hasgeek has always been at the forefront of talking about topics relevant to technologists and business. And privacy mode, where we're doing this, kind of started as an initial discussion around the data protection bill, the personal data protection bill, which we're still waiting in India to come up, and gradually moved beyond that to non-personal data, and has been kind of been on an evolution journey. And now privacy mode, which is this banner under which we're doing these sessions and these consultations, is kind of evolving into, let's say, two main things: how to get people in the industry, in the business, in product, in engineering, thinking about privacy, thinking about ethics, thinking about digitization and the impact that it has, right? Kind of what the impact of all of this is around it, explainability, fairness, all of those kind of questions. And also try to build kind of a cross body of work, consultation work, bringing in experts, bringing in ideas from different places, and integrate that as part of our entire discussion, right? So not only do it under privacy mode, but also the rest of the conferences that some of you may, or some of the you may have attended, right? Like RootConf or Fifth Elephant, where we've been talking about data analytics and data related stuff for the last 10 years, right? So that's what we are trying to do. We're doing this talk, and so my name is Amit Kapoor, and I'm just going to be kind of moderating this for the next 3 sessions. And these first 3 sessions are really around data governance, right? And we are doing it in partnership with the Human Colossus Foundation, which is a Swiss-based organization, a nonprofit organization, and they've been really coming together and thinking about, even coining the word called dynamic data economy, and trying to think about when we are now living in this, digital world, what are the interactions around that? Do we need to rethink about how we govern data, and how do we get people to be understanding their rights, but also get a data governance framework that they can do, right? So it started in 2020, and these next set of speakers are the 3 founders from the Human Colossus Foundation. And what we want them to do is, kind of bring their perspective, set this topic up and make everyone, at least starting to have a conversation around that, right? So these 3 conversations that we will be having, the first one today, which is on decentralized semantics, the next one on decentralized authentication, and then the third one on distributed data governance, right? So these are the set of 3 talks or 3 participations that we will be having. And the broad format that we will have for these entire 3 sessions is we'll have one of the founders, which is Paul in today's case, come in and set the context. So there'll be a presentation for about 40 minutes. This talk or this kind of dialogue is being both playing out in YouTube, and maybe some of you are looking at in Zoom, and we're recording it on Zoom, but it's also there on a YouTube live stream. So you can watch it there, and then you can ask questions both on YouTube, or Zoom, and Twitter while the speaker is speaking through this, right? At the end of the session, or once the presentation is over, when the speaker is finished, we will take some of those questions, especially from YouTube and Twitter, and kind of play it back and start the dialogue. And if you are on Zoom, you can also, come onto the mic and ask the question yourself, right? So that's kind of the format that we follow for this talk today, and the ones coming afterwards, right? So let me kind of set the scene for today. So today's talks is kind of the umbrella talk. So Paul, who is really a pioneer in this big data initiative, he's a head of the advisory council at the Human Colossus Foundation, based out of Geneva. Also chief data officer, has been a chief data officer, and he's really kind of thinking about the overlay capture architecture, which is kind of like rethinking how we should be building data governance, data capture, semantics around all of that, in the way that maybe some of us understand as data models and data representation. But how do we take that data model, data representation, and do that in this kind of new world that they are? So he's really been at the forefront of thinking around these topics, and he obviously has had a long career in data science, especially in the healthcare world, arena, having worked with many of the pharmaceutical companies or healthcare companies like Roche, Novartis, GlaxoSmithKline, Amgen, Pfizer, around that, right? So let me pass this on to Paul. And Paul, if you could, come on and, take the baton and take us through and set the context of this coming 3 sessions. And over to you.
Perfect. Thanks, Amit. Very, very kind. Let me just share my screen here. Make sure this all works. Good. Hopefully you can see my screen. I thought to frame this this talk, so you'll see that this is about decentralized semantics, but this talk is followed up by a talk from Robert Mitwitsky on decentralized authentication, and then the third week is on distributed data governance, and that'll be led by my colleague Philippe Page. So I thought the best thing to do is kind of frame this as give an overview of a dynamic data economy, and that's really a decentralized trust infrastructure for safe and secure data exchange. So I'm just going to move this guy. Okay, so what is the dynamic data economy? So it's a decentralized trust infrastructure, acutely aligned with the European data strategies. So as many of you know, in Europe, there's been a huge drive and quite a lot of finance behind this kind of paradigm shift of data management that we're about to embark on. And really, this is where the actors have the ultimate aim is for actors to have transactional sovereignty to share accurate information bilaterally. But in order to do that, we need to underpin these distributed data ecosystems with governance and semantics and authentication. So this is the master mouse model. It's basically a fractal model, so you can use this model kind of internally within an organization or externally within a distributed data ecosystem. And one of the things we always say at Human Colossus Foundation is, data is like electricity. So it has value when it flows, but it's costly when it stagnates. And that's really where the dynamic part of the data economy comes. The dynamic meaning the movement. So it's really about the movement of data. So just very briefly, what's in here is everything is citizen-centric. And we've also got a space here for guardianship. So, for instance, if a citizen has dementia or something like that, then some of the legal authority might be pushed over to a guardian. So that's those two spaces at the top. And then we kind of look at this as very much as a service model. So purpose-driven services as opposed to insights-driven services. Purpose-driven services could be anything from a taxi service to a clinical service, but that's really where new data is captured into these distributed data ecosystems. And on the other side of the model, there is insights-driven services. So organizations or individuals that are searching for existing data within the ecosystem. And then kind of gluing all of that together is this idea of a data governance administration, where they set the policy and notice the rules and regulations for safe and secure data sharing within their ecosystem. As I mentioned before, there's synergistic data domains that all have to kind of work harmoniously together. And the DDE concept gives equal weight of importance to 4 core data domains. So the semantic domain, which is really about data capture and objectual integrity within the system. Inputs domain is about data entry. Data inputs, so that's about the factual authenticity of any events in the system. So any temporal events. So basically, as soon as you mark something with a signature, then you can consider that to be a fact. Then there's the governance domain, which is all about data access, and that's really consensual veracity for the policy and notice and regulations for the ecosystem. And then once we've got all of that underpinning the ecosystem, then finally you can talk about the economic domain, which is about data exchange. And we call that transactional sovereignty. So interestingly, in the transactional sovereignty part, that's also where you can have you sort out consent agreements. So you can really only agree to something once you have a peer-to-peer relationship with another entity. That's transactional sovereignty. And this is a model that's taken us literally, I would say about 3.5 years to settle on this model. It's taken a long time. I've learned in this space that patience is a virtue, and we've listened to experts in all of these domains: the semantic, inputs, governance, and economic domains. But just very simply, what you can think of it is the semantic domain is all about objectual integrity, is about the objects in the system. The inputs domain is about the events and the factual authenticity of events in the system. The governance is about the rules for policy, and consensual veracity is the governance domain. And then finally is the economic domain, which is about transactional sovereignty. Where you agree to data sharing and consent. We have a stack at Human Colossus that we built, the DDE Trust Infrastructure Stack, and this is very much ordered. So we say that if you put rubbish into the system, you'll get rubbish out. So we really start with the semantics and the objectual integrity, and that's really about the data harmonization within the ecosystem. That's once you have that, then you can look at the factual authenticity, which is really about the data provenance, where the data's come from. And to have that like a verifiable or auditable chain of provenance as the inputs domain. So those first two layers is really all about the machines. It's about cryptographic assurance. And then once we have that digital network in place, then we can put the human domains on top of that. So you've got the governance domain at layer 3, which is, as I say, the policy and notice and the rules and regulations within a distributed data ecosystem, and then finally the economic domain about transactional sovereignty between bilateral exchange in a peer-to-peer fashion. And those top two layers are about human accountability. So we talk about a trust infrastructure is equal to cryptographic assurance plus human accountability. So for this particular series, we're really concentrating on the underpinnings of enabling that, that transactional sovereignty from the economic domain. So we won't go into the economic domain too much, but more about the underpinnings of the ecosystem to enable that to happen. As I said, the DDE is a next generation data agile economy offering a new paradigm in digital living, interaction, and growth, with a vision of empowering people and businesses to make better informed decisions based on insights from harmonized, accurate data framed by sound data governance. So this week I'll be talking about decentralized semantics. I'm very much a semantics nerd, if you like. I've been working in semantics for the past nearly 30 years in the pharmaceutical industry, where we have to deal with a lot of data, you know, to enable drugs to be approved by the FDA or the EMA. So yeah, I know a lot about semantics. So I'll be talking about that this week. And then next Tuesday, my colleague Robert Mitwicki will talk about decentralized authentication. And then in the third week, Philippe Page will be talking about distributed data governance. This is what we call the accurate data pyramid, and it kind of very much goes about what I said before. So we kind of start with the data integrity. You know, what is it? And that's the deterministic objects. And this is this. And traditionally, you can think about this as data management. The core characteristic here is about data harmonization. Once that's in place, you can look at the next layer, which is authenticity. Where does the data come from? As I said, it's about provenance. So factual authenticity of the information being entered into the system. And you can think of that as key management or keys management. And then finally, the third layer there, governance. Think about it as access management. So the epistemic rules for policy and notice to enable consensual veracity within a distributed data ecosystem. Okay, that's enough of the overview. I'll get straight into the decentralized semantics part. And really, decentralized semantics is thinking, it's kind of a new way of thinking about semantics. So it's really about separating the semantic tasks for maximum interoperability. And as I go through this presentation, you'll get a better idea of what that means. So first of all, for those new to semantics, what is data semantics? It's the study and the meaning and use of data in any digital environment. In data semantics, the focus is on how a data object represents a concept or object in the real world. And within the semantic domain, the core foundational characteristic is objectual integrity. And objectual is an important word here, because objectual means not just the objects themselves, but also the relationship between objects within a system. So that's also and integrity here means that you always know that that the identifier of the object is always going to be the same object wherever you see that identifier across any data ecosystem. And that provides the overall accuracy, completeness, and consistency of objects and their relationships. In the four domain model that I showed you before, this is what we'll be talking about today, is this top left one, which is all about digital objects. Yeah, I don't. You can ignore most of the words here. I won't go into that amount of granularity at this stage, because I've got another slide later on that goes into it in a bit more detail. But the important thing to note here is that really data is the kernel of the entire entire economy. So here you can see that all of those four domains, they kind of link to data, in whether it's capture, entry, access, or exchange. There's a few core DDE principles for the semantic domain. So we basically we built on top of the FAIR the FAIR principles, which I'm sure many of you have probably heard as you delved into the semantic space. But we really add these four additional items here. So rich contextual metadata, the captured context and meaning. The metadata for all payloads must be rich enough to ensure complete comprehension by all interacting actors, regardless of written language. Structured data forms, so obviously forms for when you capture data. Data governance administrations must publish structured data capture forms, specifications, and standards driven by member consensus for a common purpose or goal that will ultimately benefit the global citizens and legal entities they serve. Harmonized data payloads. This is really the key here. And I'll be going into data harmonization a little bit further into the slide, but this is really the crux of decentralized semantics and what it can offer. There's two areas of distinction to consider. There's data harmonization, which involves transforming data sets to fit together in a common structure. And then there's semantic harmonization, which ensures that the meaning and context of the data remain uniformly understood by all interacting actors, regardless of how it was collected initially. So harmonized payloads are a must for multi-source observational data to ensure that the data is in a usable format for machine learning and artificial intelligence. And then the last one is deterministic object identifiers. And this is really important when you talk about distributed data ecosystems, because as I said before, we're looking at a paradigm shift, and you're no longer looking at these kind of centralized silos of data where they might be naming their identifiers however they like. As soon as you go into a distributed model, the identifiers should be deterministic for all objects. So if the result and the final state of any operation depends solely on the initial state and the operation's arguments, the object is deterministic. So all object identifiers must be resolvable via the object's digest to be deemed deterministic. This is the digital network model. We also have a socioeconomic model, which kind of delves into the governance and economic domains. But really, at this stage, we're just talking about the digital network. So this is really about objects and events. The objects obviously sit in the bottom hemisphere here in the semantic domain, and the events is about the factual authenticity of what's put into the system. So the data inputs. So that's in the northern hemisphere, and really we built this model as a yin yang model. So there's always an opposite on each side of the model here. So and the way to think about this model is, we can start with a schema and a record. So they're really the persistent objects in those two spaces. A schema is really where you add the structural integrity of the objects. And then on the other side, how that information is stored. It's usually stored as a database record, so yes, schema and record are the opposites of each other. I separated here the form and the credential. For those of you working a lot in the SSI space, they talk a lot about credentials, and a credential is a transient object that will allow you to do something. But how you capture that information that goes into a credential is usually from a form. So if you think about, your driving license, you have to fill in some information in a form, and then you hand that to an authority, they stamp it, and then they give you the credential, which is your driving license. Everything in the semantic domain is about has to be deterministic. You probably heard the term immutable data quite a lot. Well, actually, in a distributed system, immutable is not particularly useful because you might have a scalability issue with that. So we talk about deterministic objects in this case, and really that means that if you have the authorization to delete an instance of an object, then that's totally fine. You can do that. It's not immutable. It's deterministic. So wherever that object, that identifier ends up in any system, it's the same object. In the middle there, just around the horizon, you'll see that's data entry versus data capture. Active and passive. Active basically talks about control. So obviously, if you enter information into a system, somebody has to control that information. So you sign it, and then it becomes a fact. On the other side of the model, the semantic domain, we don't talk about control at all. It's more about a language rather than control. And I can kind of explain a little bit about how, if you issue something, how you know that's issued from a certain legal entity. Okay, so what is decentralized semantics? It involves separating all semantic tasks into separate objects so that different entities can act as custodians to those granular objects. And I'll show you a couple of diagrams of what that looks like. Here you go, that's what it looks like. So, okay, so this is really about maximizing interoperability within the semantic structures within a distributed data ecosystem. So you can kind of think of a capture base as your a schema in its most basic form. The only thing that a capture base has is it also has a flagging block where the issuer can flag any sensitive information within the capture base. But literally everything else is a separate semantic object that you can cryptographically link to that capture base. And here, you've got obviously you got the semantic box there, the inputs box, and that's the transformation box and the presentation box. And I can go into those in a little bit more detail in a minute. Oops. Hang on, I'm just going to move the chat. I've somehow, oops, go away. Oh, sorry about that. I've just lost my way. Let me see if I can get this chat out of the way. Oh, excuse me. I'm just going to escape for a minute while I just move that chat. Okay, let me try again. Okay, here we go. Okay, so why do you want to decentralize semantics? So I thought I'd start this with a question here. So, how can insights-driven services perform accurate criteria searches within a distributed data ecosystem that supports semantic properties from several data models or representation formats? So, a good one to think about is, the healthcare sector. In clinical research, they use data models from CDISC. More in the exchange of health records in the hospital side, they use HL7 FHIR. And then there's also a big European project called EHDEN, EHDEN, and I just noticed that the data model they want to use is called OMOP. So, how are you going to get these data models or representation formats to be able to understand each other? And that's why decentralized semantics is really important. So the answer to this question is data harmonization. So this is a picture of a distributed data ecosystem, another visualization of it. But all this really shows is that the citizens are kind of they need to interact with these distributed data ecosystems. So you'll see the citizens are all in the ring around the data ecosystem. The purpose-driven services, if you'll remember from the master mouse model, is where new data is entered into the system. So in this case, I've put here the data capture ring, if you like, and there's a bunch of icons for purpose-driven services. And then kind of pinning all that together is the data governance administration for the ecosystem. And you can see a few of the icons in there, the rules, what's the legalities behind it, the standards, transparency, policies, requirements, and regulations. Okay, so I said that the core part of decentralized semantics is really data harmonization. There's just no way of being able to find the information you want properly without harmonizing the data, and the transformation overlays can basically be held by the purpose-driven services. They can be controlled by the purpose-driven services, and then cryptographically linked to a capture base to harmonize that information. So you can kind of think of, we've got 4 transformation overlays I've mentioned here. One's obviously for unit mappings, the other one for attribute name mappings, entry codes, perhaps you need to map those, and then standards mapping. That's more of an informational piece. So, you're going from one standard to another standard. So there's a couple of interesting use cases that decentralized semantics brings about. One of them is internationalization, which is a common problem within within data management. And internationalization is the action or process of making something international. So the internationalization of transient digital objects across distributed data ecosystems is essential for service providers to participate in a global market. Traditionally, presenting information for a purpose-driven activity in a language understandable to all recipients has involved replicating digital forms, credentials, contracts, receipts into various languages based on user preferences, with federated or centralized governance authorities maintaining digital objects in multiple languages. Internal data management inefficiencies are common to many organizations, institutions, and governments. So in this particular example here, we're looking at we're really looking at Switzerland as a quadrilingual country, where the national languages are German, French, Italian, and a minority language called Romansh, which I'm sure not many people on the call will have heard about. Decentralized semantics is well suited to represent this principle in digital information systems. Since Switzerland is a federation, the sovereign cantons can define their official language according to the primary language spoken in their region. So for instance, here I've said, okay, the Swiss government can be issuing a capture base and some core overlays, but maybe some of the language specific overlays can be controlled or have custodianship from the cantonal regions, for instance. This is another use case is presentation. So this is really about the ability to cryptographically bind presentation overlays to the standard capture base used for authentic data entry. So in many presentation instances, the legal entity that issues the original capture form may differ from the entity that issues the presentation objects required to produce an associated credential. For example, national passport issuance provides an opportunistic use case to demonstrate the advantages of this particular characteristic. So I don't know if many of you guys know ICAO, that's the International Civil Aviation Organization. So they're a specialized agency of the United Nations tasked with planning and developing standards for safe international air transport. But they've actually, they've got a lot of standards for machine readable passports. And they can define, they could be the custodian, if you like, of the data capture form for the information for anybody globally to capture the information for a digital passport. However, for the presentation objects needed to produce a national passport, the custodianship would differ. So as an example for Switzerland, the Swiss government is the authority to act as the primary issuer of, in this case, the presentation overlays for the passport, whereas maybe ICAO could be the controller of the initial capture base and some of the core overlays. So it's a really interesting dynamic that we're looking at here. You can really, it's really about a multi-stakeholder collaboration in building semantic objects, where literally any of these layers can be controlled by totally different legal entities or departments or different individuals can have authorization for the custodianship of those objects. So it becomes, when we talk about semantic interoperability, this kind of shows you where the power of it lies. Okay, so the final part of my my talk, I'll just make sure, how am I doing for time? Yeah, not too bad, is overlays capture architecture. So this is a global solution for data and semantic harmonization. This is something that we've been working on at Human Colossus for about the last 4 years. And it's really a technical implementation of what I was talking about regarding decentralized semantics. What does that look like when you bring it to a technological perspective? So there's the common diagram that we use. And I can go into a little bit more information here about some of these boxes at this stage. So, the semantics is really all about the context of the data. The giving meaning for the data that you're capturing. And you'll see some of those are kind of language specific overlays. So what that enables you to do is basically, rather than changing the entire semantic structure, if you wanted to change the labels from, English into, French or something like that, you could, rather than rebuild the entire semantic structure, you could just build a label overlay, which in the new language, slot that into the stack, and then at the resolution side, then you have the option of going into that new language. The inputs box there is all about data inputs. So this is where you can put a little bit of control around what people are entering, which is obviously really important when you think about data insights and analytics. If there's too many free-form text fields floating around, then it becomes a potential point of attack, but also more importantly, is not particularly useful for data insights. The transformation overlays there, that's really about making sure you can go from the current way that you're capturing data as a service provider, and mapping to a consensually agreed data capture specification from the data governance administration. And then finally is this presentation box, which allows you to present different objects, still cryptographically linked to the same capture base, but different legal entities could be controlling those different objects, whether it's a credential or a receipt or a contract or a form. It doesn't matter. Different people can be controlling those. Okay, so what is overlays capture architecture? It basically represents a form, which is domain agnostic, and a schema, which is more domain specific, as a multi-dimensional object consisting of a stable capture base and interoperable overlays. I'll just go into that a little bit of the difference between a form and a schema. So certainly, from my experience with clinical data management, usually you would have some sort of schema representation as a domain, if you like. So it's something like demographics or adverse events. They would be held as records within two different domains, whereas a form is domain agnostic. So on a form, you could be capturing information that might go into multiple records held on databases, if you like. So it's domain agnostic. So by introducing overlays as task-orientated linked objects within the OCA bundle, the architecture offers an optimal level of both efficiency and interoperability in alignment with FAIR principles. And it's really primarily been devised for semantic object interoperability and privacy-compliant data sharing. OCA is a proposed global standard for data capture that promises to significantly enhance the ability to define, manage, and use data in terms of simplicity, accuracy, and allocation of resources. Sorry, every time I click on something, a new pop-up comes up. Hang on, I'm just going to move this again. There we go, and start again. Okay, so why OCA? So as I said, it really offers a solution to harmonizing data between data models and data representation formats. The key benefit of OCA is that different actors from different institutions, departments, etc., can control specific task-oriented objects within the same OCA bundle. In other words, different actors may have dynamic control over assigned overlays rather than the entire semantic structure. Object interoperability is in a data agile economy where multiple institutions can participate in complex use cases. So if you think about something like a global supply chain, for example, this is where OCA can be particularly useful, because you can't expect everybody to be on the same network within a global supply chain and able to communicate with each other. And really OCA enables different parts of these semantic structures to be controlled by different people. So when you think about a global global supply chain. For instance, if you're dealing with suppliers in Japan, those Japanese suppliers could be controlling language-specific overlays into some of the data objects, which are obviously globally recognized by the data governance administration for that ecosystem. Here's some core OCA characteristics. Task-oriented objects, content-bound objects, deterministic identifiers, simplified data pooling, stable capture bases, flagged attributes. I'll show you flagged attributes in a minute. You'll see some code in a second. Internationalization, object presentation, composability. OCA is totally ontology-agnostic. And then you can have multiple issuers, and it works cross-platform. So what is a capture base? So a capture base is a stable base object that defines a single data set in its purest form, providing a standard base to harmonize data. The object defines attribute names and types. The construct also includes a flagging block, allowing the issuer of a form or schema to flag any attributes where personally identifying information may be captured. It could be PII information here, but it also just might be sensitive information that the issuer wants to flag, and that's totally fine. We don't say what to do with those flagged objects, but at least they're flagged, right? So as soon as they go into a distributed data ecosystem or across ecosystems, when it comes to encrypting that information, you know that it's already been flagged. So it just means that all corresponding data can be treated as high risk throughout the data lifecycle and encrypted or removed at any stage, reducing the risk of re-identification attacks against blinded data sets. For those coders on the call, you'll probably be interested in seeing a little bit of code. I'm not going to obviously show you every single overlay, because that kind of that's way over the top. We don't need to do that because they all work in a similar way, but I'll show you roughly how they work. So you'll see here in the capture base, it's really, there's two main blocks here. One's the attributes themselves. So you have the attribute names, and then we've got some core data types that you put in here, and they're defined in the OCA specification, which is the last slide that I'll show. There's a couple of links where you can see those. And then there's this flagged attributes. So that's obviously where you flag any either personally identifiable information or sensitive information. You can flag them in that block. And apart from that, it's just a very simple bit of metadata at the top there. So you can see the type of the object is a capture base, and the classification is where you can put in some broad categorization. So if you wanted to say, okay, this schema has come from the pharmaceutical sector, you can put a GICS code, which is a global industry sector classification scheme. I think that's what it stands for, something like that. But basically that 8-digit code there it goes quite granular, and it enables you to go into a subsector of an industry sector. So, you know, for instance, something like healthcare, it can go down as granularly as people building medical devices, for instance. I think that would be an 8-digit GICS code. So that's all that's in a capture base. Very, very simple object. And then what is an overlay? So these are all the linked objects that I showed you before. So these overlays are cryptographically linked objects to that base object, and they provide layers of task-oriented contextual information to the capture base. So any actor interacting with a published capture base can use overlays to transform how information is displayed to a viewer or guide an agent in applying a custom process to captured data. And here, this is a little bit of code. So we have a whole bunch of overlays. The entry overlays are, for me, are one of my favorite overlays, because I hate free-form text fields. I realize that every now and again you do have to have them, but I try and ban them if I possibly could, because they're no use for insights and analytics. So the entry code overlay, basically, there's two overlay types that are kind of linked together. One's an entry code overlay and one's an entry overlay. And the entry code overlay is the coded values that you can do your insights on or your analytics on. And then the entry overlay is the human readable version of those coded entries. So the entry overlay is actually language specific. So you could change that into multiple different languages, but obviously the entry code underneath stays the same. So there's a couple of things in here to show you. You always have a capture base at the top. So that's a deterministic identifier of the capture base. So it's always linked to a specific capture base. And then you see the type here. This is an entry code overlay. And then you have your entry codes here. So, document type, in this case, 0 equals passport as your kind of English version, if you like. That's your default. And then where you see these deterministic identifiers for issuing state and issuing state code, I'll show you what that means. So basically, well, what it basically means is that you can point to another deterministic table somewhere. You might have a code table with, the code, a bunch of codes. Think about something like country. You'll have like the ISO codes down one side, and then you'll have the human readable countries, and you could do that in multiple languages. So this just gives a pointer to some of these objects, which may be controlled by, in this case, ISO. And that's it. That's all that's in an overlay, really. And all the overlays are very simple, but they're all task specific, so they're very granular in what they can do. This is what I just mentioned. If you wanted to cryptographically link to an external code table, you can do that. So a code table, also known as a lookup table, is an array that replaces runtime computation with a simpler array indexing operation. The savings in processing time can be significant because retrieving a value from memory is often faster than carrying out an expensive computation or input-output operation. And an OCA table is just simply just a lookup table that OCA can ingest. So this is kind of more of a visualization of a data form. This one's for a data agreement, but it could literally be anything. And a couple of the overlays here on, I just wanted to kind of show you how the different parts of that form are constructed with different overlay types. I won't do it in this particular slide because I break it down into separate slides. So here's a meta overlay. So a meta overlay is a core linked object that defines the contextual metadata about the schema, including the schema name, description, and broad classification schemes. So in here, we separated this object out because when we first built OCA, the entire form was, we could translate it into a different language, but for, the title of the form and the description was always kind of stayed in the same language. So we separated that out so that can also be done in different languages. An entry overlay, as I just mentioned, an entry overlay is a core linked object that defines predefined field values in a specified language. It's good practice to avoid implementing free-form text fields wherever possible to minimize the risk of capturing unforeseen personally identifiable information or quasi-identifiable information or sensitive information. This overlay type enables structured data to be entered, thereby negating the risk of capturing and subsequently storing dangerous data. So you can think of these as, on a form, the scroll down of the predefined entries. They're all defined in the entry overlay. And as I mentioned before, there's an entry code overlay underpinning this overlay as well. So they kind of work in tandem. The entry code is about the codes, and then the entry overlay can be done in human readable languages. Label overlay. So the label overlay defines both attribute and category labels for a specific locale. Again, it's language specific. So it can be done in multiple languages. This overlay type enables all labels to be displayed in a preferred language at the presentation layer for better comprehensibility to the end user. And finally, I think this is the last one I'm going to show. As I say, there's a whole bunch more overlays, but these are kind of the core ones that you pretty much have to use anytime that you build a data form. So the information overlay defines instructional, informational, or legal prose to assist the data entry process. And what's really interesting about the information overlay is so the information that is displayed on a data capture form might be different to some of the information displayed on a credential, for example. And by separating out all of these kind of objects, we enable that kind of functionality between the different data objects. So you can have different information for different elements. But all cryptographically linked to the same capture base. So that's kind of interesting. And what's the main significance of transforming different data models and representation formats into OCA? So you have to excuse me, I'm just going to read this slide. But OCA provides a fundamental step in building digital objects that, when resolved at the application layer, maintain the semantically rich definitions to ensure that the meaning and context of data are uniformly understood by all interacting actors, regardless of how it was initially collected. In doing so, all transient objects, when I talk about a transient object, it's things like forms, credentials, contracts, receipts, and documents, plus the records. So the records is not so transient. The records are more persistent. But in this case, you could have records held in transient containers. So some of you will know things like solid pods or authentic chain data containers or semantic containers, where you could have an authorization credential that provides transitive trust for authorized access into those containers. So all of those sorts of things, OCA can deal with. And by building it within OCA, you can then start working with harmonized data, which, when pooled, provide a cleaner fuel for better AI, statistical analysis, machine learning, and other insights-based solutions for a specified purpose. You'll probably notice that in this presentation, I haven't really talked about AI, and I don't know that AI is a hugely important topic, but the way that we look at it is there's no point really looking at ethical AI unless you've got the data harmonized within these ecosystems, so that your AI algorithms are working off accurate data. So in terms of data harmonization, earmarked inputs from multiple sources can serve a common purpose, but obviously those source inputs need to be transformed into OCA structures so that you can harmonize the semantics, and only through this data capture process can the benefits of structural and contextual harmonization occur. There's a couple of links here that you guys might be interested in. I've got the official OCA website there, so you can take a look at that, and also how you can contribute to the OCA specification. It's totally open source. The license that we use in there is it's an EU public license at the moment, but it's pretty much the most friendly license that you could possibly use. So we've gone with that one. The only thing that we're trying to do with the licensing is to ensure that that people don't just take the code and rebuild another semantic architecture, because that obviously starts to fragment things again, which we really want to avoid. But it's really this is really a global community initiative to build out the specification. And we're not going to have covered everything in the OCA spec so far. Really, as you get new use cases that are using OCA, we might need to build a new overlay type. And where it says here how to contribute, that GitHub link is where you can ask questions, or if you think that we don't have the overlay types for your use case, then we can go about as a community building another overlay type to ensure that the architecture can deal with your use case. So go ahead and have a look at those links. I've also put my my email address here. You're more than welcome to email me directly with any questions. It's paul.knowles@humancolossus.org. We're a friendly bunch. We are not. We're very collaborative in the way that we work, and we look forward to new use cases, new projects, new friends as we go. And although we're a non-profit Swiss foundation, the reason that we built it in Switzerland is because the foundations in Switzerland are incredibly neutral, and that was really the idea when we built this foundation, so that there's no risk of centralization or anything like that with some of the IP at the foundation. It's very much meant for a global contribution. So that's everything from my side, Amit. I will stop sharing here, and hopefully.
Paul, thank you so much. Yeah, this was really useful. I think I think a lot of engineers on the calls are normally familiar with kind of the OCI layer 7s, like 1, 2, 3, 4, 5, which is used in data communication application layer. And I think what you've at least set up initially as like these 4 layers around object input, governance, economics, I think gives us a really nice vocabulary to kind of start talking about this. And I think that's really, really important. And also, I think people should go to the links that you shared at the end, because if Paul's been setting the context, but for those of you who are trying to think about how to even start using it, there are actually libraries and tools around the overlay capture architecture. I can even see like a data form and a view library around there. So even if you want to start doing it in your ecosystem, like, as a business, it may be useful to start thinking about and building around this stuff to do that. So yeah, the links are, I think Paul's just shared it on the chat also. So that's really helpful. And I also like the idea of factual and semantics. We don't talk so much around all of this in this explicit way around presentation versus semantics. We talk a lot more about syntactic transformations and syntax, but the basic challenge in businesses around data capture, catalogs, harmonization, even within organization, is tremendous, and we don't have a good shared vocabulary across everyone to talk about these layers.
Thanks, Amit. Just on that point, I just wanted to just kind of those 4 data domains that we've kind of brought there, they've taken a long time to really try and separate those out. And one of the reasons for doing it is that we needed a communal language that everybody could use without tripping over each other. So obviously, when the data management guys talk to the identity guys, they talk a totally different language, and same with the economists and the people that are setting up governance frameworks. And just to give you an example, in the economic domain, we were working with somebody that started to use the word attributes, and I said, you can't use that. This is like, the data management will go nuts if you take that term, right? So he said, what term should I use in the economic space? And I said, well, just think about like everyday life. When you go to an auction, it's the next item for sale is this, or you talk about itemized receipts, or itemized billing and that sort of stuff. I said, your core term there is item. Use item. And then he totally adopted it. And what was cool with that is that now we can talk to each other and say, okay, we talk about asset exchange and items. That's in the economic domain. Attributes and schemas is kind of left to the data management people, and really trying to kind of separate those domains. So that was it was good fun. Well, I'd say it was good fun. It was like plucking teeth sometimes, but we got there.
No, I think that's ready to. I'm gonna wait for some questions, but like I think and see if there are any questions. But let me ask you one. I think this internationalization example that you shared. I know you talked about Swiss and the cantons. In India we have the same challenge, right? We have many languages. We have state languages and federal system like similar to other countries, some of the other countries, and I think what you've just talked about also is quite relevant in terms of thinking about internationalization and localization for governments and public services in some way. And I feel like, at least in India, where we are still in the infancy around that, we have not articulated that all our services have a different presentation layer or a different information layer. So any pointers from how you've seen that happening in your region or in Switzerland that you think we should be thinking on just on a public domain kind of services?
Yeah. I mean, well, the one thing that I've always loved about the decentralized semantics is that it supports minority languages. So we've done a lot of work with the Canadian provincial governments, and they obviously have the First Nations in Canada, where some Inuktitut is like a language of the Inuit people, and those languages and cultures are in danger of dying. But what's nice about all of this is, it enables the experts in those languages to be able to do the translations and have full custodianship of those language overlays themselves, and then it puts less pressure on the federated system, on the federated government themselves, right? I know that over here, Romansh is a minority language in Switzerland, but nothing is translated in Romansh, and I don't think the government could even do it, because I don't think they've got the expertise in that language. It needs to go to that canton with that speak that language, and they should be controlling those languages. Yeah.
I think it's a great point. We should be thinking much more on that direction even here. We have one question from Sankishan. Let me hand it over to him. Sachin, do you want to come on the mic? And go ahead.
So fantastic exposition from Paul. Looking forward to the next two as well. This is probably the second time I have sat through a presentation on this topic, and I have made notes. I have a question for Paul that relates to some of the projects that are underway over here, particularly related to citizen services. We have a lot of legacy data, and one of the key things that happens when you're dealing with legacy data and making it more friendly, Web3, or what you want to call it, is that the project gets bogged down in the data transformation phase, by which I mean that you are taking in data that's on paper or perhaps OCR digitized in one way or the other, and then you're transforming it into records that you can manipulate, extract some knowledge out from. If I go back and look at how you describe the workflow, transformation is an integral, but not the start point of things. It's
correct.
And so my question is that how do you think we should be able to raise the awareness in those projects that deal with legacy data to start looking at the system being transitioned from system A to system B by adopting some of the principles that today you described?
Yeah, no, so good question, Sangashan. I think the important thing is that you're not going to change the way people are not going to change how they capture data, or they'll do it very reluctantly because they have these legacy systems that they've probably been using for 10 years or longer in some cases. So really, it's just about kind of saying to those people that, you can capture data that you want, but if you want to interact within a distributed data ecosystem, whatever that might be, whether it's e-commerce or it's a health or it's a financial, doesn't matter. But if you want to interact with those, all you need to do is just build some transformation overlays on your side, which you can control. And then, every time you're pushing or people are requesting data into the data ecosystem, it can automatically be transformed into that kind of harmonized solution. And that's kind of a short-term thing. Once they start doing it that way, then I'm sure they'll think, oh, you know what? It's just going to be so much easier for us to just to build our data capture straight into OCA without necessarily having these transformation overlays. But I think that's the first starting point, is to kind of really push that, we're not changing the way that you capture data at all. But if you want to contribute, you need to kind of work with the standards as the Data Governance Administration has defined.
Great, thank you.
Okay, Paul. Let me just ask one last question as we kind of close this and set it up for for the next two sessions. Semantic web. I mean, I go back 20 years. The initial vision of the semantic web never really panned out, and I give us some optimism around why this time would be different. Is that?
Well, yeah, so it's a perfectly reasonable question. I just got back from a conference in Helsinki called My Data, the My Data conference, which is really driven by data-centric organizations rather than the authentication side or the SSI side. And you can kind of, in that community, you kind of see that there's always like some like a buzzword or buzz topic within. And this year, the buzz topic was really data spaces, they call them, which is a horrible term. It's a horrible term because that doesn't really mean anything. But basically, the way that the European Union has kind of defined data spaces is what I would call a distributed data ecosystem. And the first thing that's coming up in that space, they're not really talking about semantics. They're talking about data governance. How does the data governance work for these data spaces? You know, some of it will be distributed governance. Some of it will be federated governance. Authorities will probably be, the administration is usually separate from the authority. So. So those are sorts of but the cool thing is when you talk about data governance within a data ecosystem, you very quickly get into the semantic topic, you know, because they realize that within a data ecosystem, you need to search for data, and then where do you start, right? Okay, let's look at the semantics, right? So it's kind of a very gentle, semantics is a very gentle approach into governance. And what's interesting in the 4 domains is that actually the inputs domain and the economic domain are really user driven. So it's more about like, so I enter information in a system, it comes from me. If I have a relationship with you, Amit, it's still user led. It's between bilateral communication. But the other 2 are really driven by the ecosystem. So they're ecosystem driven. So the governance is ecosystem driven, and very quickly, as I mentioned, so is the semantics, because they need to have some sort of agreement on how they have safe and secure data exchange within that ecosystem. And that's all semantics. So, yep.
I think thank you so much, Paul, for giving us a vocabulary, giving us a language, setting this whole lenses around this topic, and especially I'm hoping people will go back and share and participate in the open source or the open stuff that you're doing, and maybe also bring it to it. I think we in India definitely need it, and we are far behind on it. I'm hoping we at least start thinking about this in the government space, for sure. Even before businesses, I'm sure businesses will have their own perspective to it, but I'm really hoping in public policy it has a big impact. This session has been recorded, so we will have an edited version of this up there. You can all go to hasgeek.com and privacy mode and go from there. There's a link to data/gov/and/sem, and you can see the upcoming talks, as well as the next 2 coming talks. There's on the same theme. There's one by Robert on decentralized authentication. So we go to talk about authentication or in some way, the credential aspect that you saw in the conversation today. And then Philippe will also come back. Philippe will come back, and we'll also talk about kind of the initial set that Paul showed around distributed data governance. So how to make this all work, especially looking at the governance angle of it, right? So this talk was around schema. Next one is around authentication or identity, maybe for some, if that is easier what to think. Then the third one will be going to the human aspect, the key aspect. I think economic we all kind of buy into, but the governance part, which is going to be set up, right? This is a dialogue, and please come back, and you can post comments at the talk. We can continue the dialogue with Paul. He's shared where he's available, any responses. And if you want to come in and talk about this, if you want to come and talk around this topic on what you're doing or how you are trying to think about this in the space of privacy or data privacy, fairness, please to come back. There's also a Telegram group on privacy mode, which is welcome to join and continue this conversation with like-minded people. That's at t.me/privacy_mode. So you can continue the conversation also on Telegram. Well, on that note, and looking forward to the next two talks, I would like to thank Paul. Thank you so much for spending time with us and setting this up. And we hope to continue this collaboration and this dialogue with you and learn a lot more as we have in this session. Thank you so much.
Perfect. Thanks, Samit. Thanks for having me, and thanks for everyone for joining the call. And yeah, any questions, I put my my email in the chat there, so feel free to email me about anything you want. Right. Great. Thanks so much.